Hey guys, welcome back. Now I will be introducing another magnetic sensor, that is MMC3316xMT. Now to gain more knowledge about this sensor, let's have a look over the website, that is controleverything.com, and here search on for this sensor, that is MMC3316xMT. As you can know, you can see clearly that it's a plus minus 16 Gauss 3-axis magnetic sensor, and these are some of its features which you can notice on the screen also. Also, you can have the opportunity to purchase the sensor from this very site, right from here. I will be interfacing this magnetic sensor MMC3316xMT with a BeagleBone Black and using a C code. And to get the C code, let's go to resource tab, and here comes the C code sample. Now you can download this C code sample as a zip file from here, and you can also have the code from github.com, and the repository there is Control Everything community. Now what do we require next is to set some hardware connections, and let's see what we got there. In the connection setup, first of all, the requirement is of a BeagleBone Black, which you are able to see on my screen, and this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make easy connections with other I2C devices. So gently place this I2C Shield over the BeagleBone Black and you can have a connection like this. Now what we require next is of a sensor, that's the compass or magnetic field sensor, as you can see, MMC3316xMT. Now this here is a connecting cable. Now make sure that the connection among the sensor and the cable, the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason to the I2C Shield. Next we require to power up the BeagleBone Black, and for that there are two things we require. First of all, the requirement is of a mini USB cable just like this, and gently insert it over here, this jack. Next we require a 5-volt adapter to power up, and gently insert it over this power jack. The last thing we require is to provide an internet connection, and there are two ways which either can be used. Now the first is an Ethernet cable or a LAN cable, as you can see, and gently insert it over this Ethernet jack. The next or the other part is a wireless nano USB adapter. You can also use this if you don't have the LAN cable or Ethernet cable. Now we are done with the connections part. What do we require next is to have a look upon the C code. Well, for the interfacing part, first of all we have to log into github.com, and here we have to search for the repository, that is Control Everything community. Now here we have to search for the sensor, that is MMC3316xMT, and here it comes, it's a C code. Now let's have a look over the instructions for the C code. First of all, we have to take care of the BeagleBone Black. We have to set up and connect, and the details for the setting up instructions are provided on the link, that is beagleboard.org. So do it carefully, and after that we have to download or git pull the code on the BeagleBone Black, and we have to compile the code. This is the command, and this is the command to run the code. Please do it and note it carefully. After that, get back to the C code. As you can see, notice it's a .c file, and in the code you can see that we have included some of the header files, and in the void main function we have to create an I2C bus and check whether the bus is there or not. And after that we have to go for I2C device and the address of the sensor, that is 0x30. And writing section part, we have to select control register 0x07, and we have to send the command to take measurement continuous mode coil set 0x23, and the writing command is here, as you can see. Then we have to select control register 0x07, and we have to send the command coil not set, that is 0x00. The writing command is here. Then we have to check and select the control register 0x07, and we are sending the command to take measurement continuous mode coil reset, that is 0x43, and the command is here. And then we have delay or sleep of 1 second. After that we have a different section, that's the reading part, and we are reading, as you can see, 6 bytes of the data from the address 0x00. It's the magnetic field for 3 perpendicular axes x, y and z. Then we have a condition of checking the data whether there is an error or not, and then we have some conversion of the data takes place according to the formulas and the details provided for the data sheet for magnetic sensor MMC3316xMT. So at the end of the code, we have the output data to be displayed on the screen, and the print commands are there for magnetic field in X, Y, and Z axis. As you notice, it's the raw values which can be negative or positive depending upon the condition of the magnetic field present at that time. So do it carefully. So now what we require next is to show the working, the practicality of this code along with the sensor and BeagleBone Black. Let's add.
Now this is the very interesting part, which is to show the practicality, and it's the working environment part. And here we have to first we have to copy this entire code of this sensor, as you can see, and then we have to open up the terminal for the BeagleBone Black, as you can see, and here we have to create a new file as per reference. It's a .c file, and here we have to paste the entire code we have just copied from github.com, and after that we have to save it. And this is the command, as you can see on my screen. This is the command you have seen in the instructions part. This is to compile the code, and we are doing the same. And let me show you, and let's see what we got here. The code has been compiled, and this is to build the code as we see, and the code is here, and we have the magnetic field in X, Y, Z, which are the perpendicular axis. Now when I again run the command, you can sense and see what are the changes, but the changes are minimal for the magnetic field, but because there is no magnetic field change. But when I bring a bar magnet near to the sensor, you can see the changes are reflected on the screen, and as I am moving the bar magnet in different directions, the values is changing for the three perpendicular axes as per that. Now this is how the sensor responds to the magnetic field change, and it works along with the C code and with the BeagleBone Black. Now let's have a look over the applications and the benefits and the features of this sensor.
The MMC3316xMT is a complete 3-axis magnetic sensor with on-chip signal processing and integrated I2C bus. The device can be connected directly to a microprocessor, eliminating the need for A to D converters or timing resources. It can measure magnetic fields with a full-scale range of ± 16 Gauss with 2 milligauss per LSB resolution and 2 milligauss RMS noise, enabling heading accuracies of less than 1 degree in electronic compass applications. Due to these good features, it's applicable in a lot features like electronic compass, GPS navigation assist, positioning, sensing. This sensor is available and can be purchased from the website controleverything.com, as you can see, and you can have the code from resource tab, and you can download this as a zip file from this website. You can also have the code and you can download it from github.com, and the repository there is Control Everything Community. In the end, I just want to make it clear that in case of any part where you have some queries, you can reach us on controleverything.com, and you can post your comments on the community page of this website like this. Now for articles and blogs which are relevant to this sensor or video, you can have a look over on instructables.com, and to subscribe more video tutorials just like this, go to our YouTube channel and follow them and subscribe it. In the end, I hope you enjoyed this video and you liked it. So thanks a lot for watching.